Hey guys, welcome to Geometric Sequences. This is our fourth video here. Today we're going to find the partial sum of a geometric sequence. Now when you start adding terms to either a sequence, it becomes a series if you start adding specific terms, and we'll talk about that in later videos. But the idea here is we're just going to be able to find the partial sum. So we're going to be given a geometric sequence of numbers, and we're going to find the partial sum of maybe the first 20, the first 100. The definition that we're going to use here to find the partial sum, S sub n, is S sub n equals a sub 1 times 1 minus r to the n all over 1 minus r, and r cannot be 1 because then it would be undefined. Now we have two examples for you today. So find the sum of the first 16 terms of the geometric sequence 3, negative 12, 48, negative 192, and that pattern is going to continue, that sequence will. Now I highlighted here from 4 to 12 is negative 4, so you have positive, negative, positive, negative. So we're going to have a negative r value, and that's okay to have. And that r value is negative 4. Okay, so I write my formula, and again I color coded here so my n's match, a sub 1, and my r's match here. So I write the formula. I want the 16th term, so that means n is going to be 16. So we want the partial sum of the first 16 terms of the sequence. So then I have a sub 1, which is 3, which it got erased here. So this should be 3 times 1 minus negative 4 to the 16th. All over 1 minus negative 4. So I substitute. Again, there should be a negative 3 here. It erased when I put my boards up. So negative 3 right here. Okay, times all this, and I get this monster-sized number. So that's the sum of the first 16 terms of this sequence. In example 2, I wanted to show you another way you can look at a sum, and that's with our sigma notation. Okay, you probably watched that in the first video. So find the following sum. From 1 to 10, we're going to take the sum of 6 times 2 to the I. Now these sums should get large quickly because these are exponential functions. We talked about that in the last video. When r is not 0, it's not 1, or greater than 1, you're going to have an exponential function for these geometric sequences. So I need the first term here, so I do 6 times 2 to the 1. That's going to be equal to 12, so I've got my first term. I want the sum of the first 10 digits. Okay, so S sub 10 equals 12 times 1 minus 2 to the 10th over 1 minus 2. So there's our r values, there's our power that we need, okay, n, and 1 minus 2 in the denominator, and then we take that sum, you get 12,276. So here I just kind of formally wrote the sum from 1 to 10 of 6 times 2 to the I is equal to 12,276, so from 1 to 10. Okay, start and finish. So again, that's just finding the partial sum in a geometric sequence when I give you a sequence of numbers and when we use sigma notation. So questions or comments, you can type them below. We'll see you next time.